The star Pallas, a red, very massive monster found in the superb body of Orion, has long charmed stargazers and cosmologists alike because of its sheer size and brightness. In the event that Betelgeuse were placed where our Sun is, it would extend out to the orbit of Jupiter, affirming its colossal size. In spite of being located around 642 light-years from Earth, its gigantic size makes it quite possibly one of the most brilliant stars visible to the naked eye. Anyway, as of late, Betelgeuse has shown bizarre behavior such as amazing darkening and lighting up cycles, which many researchers believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently made a critical statement that Betelgeuse is on the edge of a devastating blast expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide a phenomenal opportunity for researchers to study one of the most surprising and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for many years, but its new eccentric fluctuations in brightness have started theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core implodes under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and cosmic material into space. Betelgeuse's approaching blast is anticipated to be a Type II supernova, a specific type of celestial explosion that happens when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that tears the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would normally be catastrophic if it happened near Earth, Betelgeuse's distance of around 642 light-years means that, although the blast will be visible and dramatic, it will not pose any danger to life on our planet. Nevertheless, the event promises to reshape our understanding of supernovae and cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will release throughout its entire lifetime. Betelgeuse's blast will not just be an astonishing cosmic display, but also a significant moment for science. Researchers are eager to observe this intriguing event from its earliest moments using a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most crucial aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the blast, due to their ability to pass through almost everything without being affected. Observatories like Japan's Super-Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in monitoring Betelgeuse's final moments. The explosion will also provide vital insights into the creation of heavy elements. When stars detonate, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer view of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have a destructive impact on Earth, it will interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could affect satellite communications and some technologies on Earth, the disruptions are expected to be minor and brief. Perhaps one of the most exciting parts of Betelgeuse's blast is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will captivate not only the scientific community but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about Betelgeuse's death, but Brian Cox's recent statement adds a sense of urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially changing our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such a blast travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clear understanding of the size of the universe. The event will also offer a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to understanding the life cycles of stars, particularly how massive stars contribute to the formation of the elements essential for life. Supernovae are the key cosmic events responsible for spreading heavy elements throughout the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The social significance of Betelgeuse's explosion is also important. For centuries, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as omens or signs of monumental change. Betelgeuse's blast may inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to reignite interest in space exploration and stargazing, drawing more people into the search for knowledge about the universe. Amateur astronomers are already preparing for the event, as modern technology allows nearly anyone with a camera or telescope to observe and record the supernova. This democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their unique vantage points. Betelgeuse's explosion isn't just a spectacular cosmic event, but also a stepping stone for future exploration. The data gathered from the supernova will inform how we study other stars, particularly as we venture further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity looks to extend its presence in the solar system and beyond. Additionally, the explosion will reignite interest in the search for extraterrestrial life. Supernovae are essential for spreading the components needed for life, like carbon and oxygen, across the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The impending explosion of Betelgeuse is set to be one of the most significant cosmic events in recent memory. Its supernova will provide a wealth of scientific data and enhance our understanding of the universe, and undoubtedly captivate people around the world. Betelgeuse's death will mark the end of a giant star, but it will also represent the ongoing cycle of creation and destruction that governs the universe, reminding us that from death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces detonates into view. For both researchers and stargazers alike, Betelgeuse's final journey will be awe-inspiring. As Betelgeuse approaches the last stage of its life, one of the more speculative but fascinating possibilities related to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These puzzling forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae like the one expected from Betelgeuse could hold the key to unlocking some of these mysteries. Supernovae release vast amounts of energy and radiation, and some researchers believe these powerful forces may interact with dark matter in ways we can observe and study. One intriguing hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs exist, Their interaction with the energy generated by Betelgeuse's supernova could provide clues to their nature. Such a discovery would be historic, offering the first direct evidence of dark matter, an elusive phenomenon that has puzzled scientists for years. Moreover, there is potential for Betelgeuse's blast to offer insights into the nature of dark energy. Dark energy is the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during Betelgeuse's supernova, researchers could gather vital data on how cosmic events like these might interact with the fabric of space and time itself. Though still, in the realm of speculation, these possibilities demonstrate how even the most catastrophic events in the universe could have profound implications for understanding some of its most enigmatic components. With Betelgeuse's approaching supernova, the door to exploring these mysteries could be wide open as Betelgeuse nears its final stages. The astronomical community is bracing for an event of profound significance. Beyond its dazzling visual display, the supernova will provide a unique opportunity to study the processes that lead to the death of massive stars, offering scientists a wealth of data on stellar evolution. Unlike smaller stars, which gradually fade into white dwarfs or neutron stars, the explosive death of a supergiant like Betelgeuse involves complex processes that are still not fully understood. The study of this explosion will improve our understanding of how massive stars evolve, exhaust their fuel, and ultimately explode in a supernova. One of the most important aspects of studying supernovae is understanding how they spread heavy elements throughout the cosmos. Elements like iron, nickel, and even heavier metals are created in the cores of massive stars and dispersed into space when the star explodes. This process plays a critical role in the formation of new stars, planets, and life itself. In fact, much of the matter that makes up our own bodies and the Earth was likely created in the explosive death throes of a star like Betelgeuse. The supernova will act as a cosmic forge, scattering these heavy elements into the interstellar medium, enriching it with materials that will one day become part of new stellar systems. By studying the composition of the material ejected from Betelgeuse, astronomers hope to refine models of element creation, giving insight into how the chemical building blocks of life are spread across the universe. The interaction between the explosion of Betelgeuse and the surrounding interstellar medium will also be of great interest to astronomers. As the shock wave from the explosion propagates outward, it will compress and heat the gas and dust in its path, triggering the formation of new stars in the process. This phenomenon, known as a supernova remnant, occurs when the energy from the explosion collides with nearby molecular clouds, causing them to collapse under their own gravity and form new stars. The shock wave will also ionize the surrounding gas, creating a nebula that will glow brightly in the ultraviolet and infrared parts of the spectrum. Observing this process will help astronomers understand how stars are born and how supernovae contribute to the cycle of star formation. Furthermore, Betelgeuse's explosion will provide an unprecedented opportunity to observe the nature of gravitational waves. These ripples in space-time, caused by the violent collapse of a star's core, were first detected in 2015, and subsequent events have revealed a great deal about the nature of black holes and neutron stars. The collapse of a star like Betelgeuse may also produce gravitational waves, which could be detected by observatories like LIGO, Laser Interferometer Gravitational Wave Observatory. This would offer another valuable data set for understanding the fundamental properties of the universe. By detecting and analyzing the gravitational waves from Betelgeuse's supernova, scientists could gain a deeper understanding of how stars collapse and how these processes influence the formation of black holes. On a more theoretical level, Betelgeuse's supernova might also help refine our understanding of cosmology. Astronomers often use the light from distant supernovae as standard candles to measure distances in the universe, and the data from Betelgeuse's explosion could improve these distance measurements. Because Betelgeuse is relatively close to Earth compared to other supernovae, it offers a unique opportunity to calibrate these measurements with greater precision, improving our ability to measure the scale of the universe. This could lead to more accurate estimates of the universe's size, age, and expansion rate, critical factors in determining its ultimate fate. The potential for new discoveries doesn't end with the study of the explosion itself. As the supernova fades and the remnants of the explosion continue to expand, astronomers will continue to study the material ejected by the star for years to come. These remnants will provide a glimpse into the future evolution of the universe, as the elements produced in the explosion mix with the surrounding gas and dust, potentially leading to the formation of new stars and planetary systems. By examining how these remnants interact with the surrounding environment, scientists can learn more about how the universe has evolved since the Big Bang and how it might continue to evolve in the distant future. The cultural impact of Betelgeuse's explosion should also be considered. Such a dramatic event in the night sky will capture the imagination of millions, from scientists to stargazers. Its visibility, potentially even during the daytime, will serve as a stark reminder of the dynamic and ever-changing nature of the cosmos. It will also spark interest in space science and astronomy, inspiring a new generation of scientists and engineers to explore the mysteries of the universe. The event will likely have a significant impact on popular culture, further cementing the role of space exploration in human consciousness. In the broader context of scientific discovery, Betelgeuse's supernova will be remembered as a milestone in our quest to understand the universe. The data collected from this event will be invaluable for years to come, contributing to fields as diverse as stellar physics, cosmology, and elemental synthesis. And as we witness this extraordinary event, we will be reminded of the delicate balance between creation and destruction that governs the cosmos, where even the death of a star can lead to the birth of new worlds and potentially new life.